grew up in a town called Hamilton, which is just outside Glasgow. I went to the primary school and then secondary school in the town, just a normal state school, and a school called Hamilton Grammar. So I went to Edinburgh and studied chemistry. And if I look back, I probably regret in part that decision. The intercalating medicine wasn't an option when I was a student, and I'd never come across biochemistry really at all. I did chemistry and physics at school, and I did no biology beyond the usual school stuff, which was cutting up bullseyes, which didn't really inspire me to know anything about biochemistry. So 4 years at Edinburgh, I got a Carnegie scholarship and went to Manchester, and I went to do a PhD there. So I switched to structural biology, and that got into enzymes and how biology, chemical molecules function in biology, and I just never looked back. So I recently just got my Wellcome Senior Investigator Award. It looks at how bacteria initiate the polymerization of carbohydrates. So they start out inside the cytoplasm. They have a lipid called undecaprenol, and you load that up to undecaprenol pyrophosphate. So undecaprenol phosphate is then coupled to a sugar nucleotide to make undecaprenol pyrophosphate sugar. That sugar then has to flip across the membrane, and then that's the building block for making polymers that get attached to the cell surface. They make capsules, the LPS molecule, and gram-negatives. It's just an essential part of their armory. Another thing we do, which is kind of wacky and interesting, and this is something I do outside. So in Hamburg, they're building an X-ray free electron laser. And the UK I led a grant for the UK to buy part of an end station, or build and own part of an end station to that. So the X-ray free electron laser shoots electrons down a magnet, which the electrons wiggle from side to side. And if you get that frequency of the wiggling right, they emit a pulse of energy. Right? And that energy is in the X-ray range. Right? So it's very high energy. But because of the wiggling path in a superconductor, you can get it so that the waves add up in the same way that a laser, so you get a laser burst. So for about 30 femtoseconds, 10 to minus 15 of a second, the power in that laser pulse is the same as in about half the national grid. So it's an immense amount of power. Right? Now, it only lasts 30 femtoseconds, but it's an enormous amount of irradiation. And that can enable new science, right? Because you guys aren't chemists, probably. You know a bit of chemistry. But you can do an experiment faster than a bond can vibrate. Right? So that means for me, for structural biology, why the Wellcome have funded this, and RC UK, why this has been funded is because you can dump X-rays into a sample faster than the sample can be destroyed. So currently, a lot of things get destroyed when we look at X-rays, and they destroy quicker than we can measure them. But now we can put 100 times more radiation in than the sample can tolerate. But the experiment is over before the atoms can actually explode. So that, I think, could really open up some new biology and new structural work.